how have you seen hydraulic system designs kind of evolving in the past few years? And maybe Andre, I'll start with you this time.
I can say I have the perspective from academia, and there is a lot that over the past years have been proposed. From industry, though, not so much as we wish, and it's always like that, right? We in academia we tend to be naive in looking at new things, and then we face the barriers about how we can actually implement.
Mhm.
But I'd like to classify the systems that what I call today is a conventional system that works great, but perhaps doesn't fulfill the requirements of future sustainable technology. And then there is a line of progression, smart components. Nowadays, everything is getting smart, and all the suppliers, the big ones, the Parker, the Danfoss, the Rexor, and I don't want to forget anything, they're proposing something on smart component with certain abilities to make the system better. But then there are also more disruptive concepts like changing the system. We like to call multi-pressure rail. Now many research institutions are working on that, and many they're working on decentralized hydraulics. So not having a system with one supply and supply several functions, but having a dedicated system, which is more expensive, but is a very promising way. So these are really the evolution that academia now is really focusing on. And let's see if they will be used someday. Yeah.
Yeah. Okay. And Matt, from your perspective, how, have you seen hydraulic systems kind of evolving in recent years?
Yeah, sure. Historically, our systems have been designed with the customer in mind. So how do we make a system that is responsive to an operator's input and provides them a comfortable and efficient machine to work with? This really involves a lot of collaboration with our product management teams to ensure we understand what the customer needs, what their requirements are, and then we can work to develop a system based on those requirements and work to refine those systems with further customer engagement and feedback. As technology progresses, the way we control hydraulic systems is changing. Prior to the recent past anyways, we didn't interrupt a lot of what was between the operator and the component they were controlling. But as you get more sophisticated hydraulics, electronic over hydraulic control, we have the ability to do that now and do that in many instances to ensure the machine is capable of operating at peak performance and give the operator a more comfortable control. So the evolution of control from that aspect is important, as well as we're starting to get into areas of semi-autonomous and autonomous control. So as we work to develop systems, we have to keep that in mind as well. How do you develop a system that has the capability to be controlled autonomously? And that many times will involve additional or different components or different requirements from just a straight operator input and control.
Mm-hmm. Right. Okay. So to kind of follow up on that then, I guess what sort of features or capabilities would Bobcat be, a company like Bobcat be looking for in its hydraulic components or systems and, that you guys would be using?
Sure. They really, for us, come back to probably two key things. One is reliability.
Mhm.
Whatever those systems requirements are, our customers expect the machines to perform without issue. And that is very high on our requirement list. So we work with suppliers, whatever technology we're working with, to ensure that that component, when applied in our machine and utilized to our customer expectations, will operate reliably in that system. Very important to our customers that, uptime for them is money. And if they have downtime, they're losing the capability to do their job. So we want to ensure those components are reliable. Second one is efficient. So this goes back again to the customer being able to get work done. And any inefficiency in the system is something that takes away from their ability to get work done. It also results in challenges on the machine side from a cooling perspective, from a component durability perspective. Inefficiency is heat. hydraulic oil generally doesn't like to be hot, so we need to mitigate that through cooling systems. And the more inefficient a system is, the more energy you have to spend cooling that system down. So again, taking away from the power of the machine and the ability for the operator and our customers to get work done. So efficient, reliable systems are very high on our list for our customers to be effective.
And Andrea, from your perspective, are there, features or capabilities you guys are seeing from maybe the companies you work together with at the Maha Fluid Power Center that, people are looking for from their hydraulic systems? Or...
Yeah, and I'd like to second what Matt just mentioned. There is obviously I would make the similar points, of course not from the UAM perspective, but from what we keep hearing with our partners. I'd like to add some trends that I see now. We need to make our hydraulic system more environmental friendly, which involve also the use of bio oils. And I see challenges that component suppliers are facing in switching oils. So that is a requirement that we see having. Then the electric integration that affecting particularly the smaller off-road vehicles is bringing two new components. The traditional components like the pumps, they meet the RPM of the diesel engines is very different with electric motors, and so that is how will be the future line of products. We see a lot now happening, and that is certainly something that we'll see in the future. And another trend that I keep now hearing is the digitalization of systems. So more and more we'll see components be able to dialogue more with the control unit, allowing the hydraulic technology to enter into the world of the big data that is really new for ABD in many applications, but it will really make the system more efficient and increase the cost of ownership, and increase the cost of ownership for, I think, for people. If we have components that can tell that are going to fail and communicate to the system and perhaps reorder the new parts in an automated way, that is something I think that I see many that are working, and there is research on that as well, and I believe it is tomorrow already, and many companies they even claim that is already today. So more and more we will see that.